Welcome to my kcse revision channel. Teacher James Marita, Girls Boys High School. Subscribe my channel. Click the notification bell to get notified once I upload a video. Today we are looking at electrochemistry, and that is the mercury cell. This is the application of electrolysis. Electrolysis, we studied electrolysis in Form 2, that is the effect of electric current on substances. And we have electrolysis in chemistry, so in electrochemistry. So one of the application of electrolysis is the manufacture of sodium hydroxide, hydrogen, and chlorine. And that one now today we are seeing the manufacture of sodium hydroxide, manufacture of hydrogen, and also chlorine using the mercury cell. We have the other application of electrolysis. For example, we talk of the extraction of reactive metals like sodium and aluminium from their respective ores by what we call electrolytic method. So electrolysis is normally electrolysis used in that extraction of those reactive metals. We can also say that another application of this electrolysis, it is used in purifying copper after extraction from the copper pyrites. Extraction of copper, the copper obtained is not pure, so to purify it, there is a method of electrolysis. There is also electroplating. You have come electroplating in Form 1 work. That is a method which is used in preventing metal. This is a situation where of coating a metal with another metal. So those are the various uses application of electrolysis. And today we are looking one of the application of electrolysis whereby we are using the mercury cell to manufacture sodium hydroxide, hydrogen, and of course we have chlorine. So this is a diagram of the mercury cell. We have the raw material introduced in. We have water as a raw material. We have brine as a raw material. And so the raw materials we have raw materials. That is we have brine. We have this brine as a raw material, and then we have this water as raw material. So we introduce in this brine that is saturated as sodium chloride, and then we have water is normally produced in. Look at this diagram very well, because in an exam situation, you will be told to name the raw material introduced here. So the raw material introduced in here is water in. And the substance or the gas which comes out in this region here, it is just hydrogen gas. After reaction, we have the hydrogen gas normally comes out. And of course, we have on the top at the top here, we have the hydrogen gas out. We have the brine in, and then we have the used brine out. We have the brine and used in. On the other side, we have the used brine out. And of course, on this side here, on this side, as you can see on the screen, this one is a mercury cathode, and of course, we have the anode. And you know that the anode is made up of two substances. It's either made up of titanium or it's made up of with graphite, because titanium or graphite does not react with chlorine. So, what are some of the important things you are supposed to know from kcse? The anode is made up of graphite or titanium. So the anode is made up of, it is either made up of graphite or it's made up of titanium. So two substances which the anode is made of is either made up of the graphite or made of titanium. And the reason why either graphite or titanium is used is because they do not react with chlorine. The cathode consists of the mercury. So you can see this region here. This is the cathode, the mercury cathode there. That is the mercury that we have. So you need to know the reaction. What are the reactions that takes place in each electrode? So we have the anode, and the anode. So look at the anode here now. At the anode we have the observation you can see there, it is a green gas which is produced, and of course that one is chlorine gas, because the chlorine ions are discharged due to its high concentration. When the chloride ions are discharged, we see a chlorine gas which is green. So the most observation you can make here is that there is a green gas, and this green gas is nothing else apart from the chlorine gas. So you can see here, this one here, we have the chloride ions, it is discharged due to its higher concentration, and therefore we have a green gas which is chlorine gas. And the cathode, we have several reactions which takes place here. We have several reactions. We have sodium ions. We have sodium combining with mercury. Then we have sodium amalgam combining with water to form sodium and sodium hydroxide, mercury, and then we have water. So we have, this is a sodium hydroxide solution. So this region here, we have, this is sodium hydroxide solution. The sodium hydroxide solution now, it will be reacting with this water. Sodium hydroxide will react with that water. Then you have sodium hydroxide, mercury, and then you have hydrogen gas. But before that, sodium ions at the cathode, the sodium ions are discharged due to its high concentration. That is why now there is a formation of sodium here. The sodium formed now, the sodium atom formed here, it combines with mercury in the sodium to form sodium amalgam. So there is this sodium which is produced here. The sodium which is produced here combined with mercury. Once they combine with mercury now, there is a formation of sodium amalgam. So the equation of the reaction, as you can see, we have this sodium which is produced from here, which has been discharged. It combines with mercury, and then it forms sodium amalgam. The sodium amalgam now here in this, as you can see, we have water and then we have sodium amalgam. The sodium amalgam here in this case, it reacts with water to form hydrogen gas, and then we have sodium hydroxide. So in this idea, we can have this water and then we have this amalgam. So when water is introduced in, we have the amalgam here. They will react. Once water and this amalgam will react, they form two products. That is sodium hydroxide, and then you have hydrogen gas. So that is why you have the hydrogen gas out here, and then we have sodium hydroxide solution on the other side. So another important thing here now, the amalgam, so we have the sodium in the amalgam now. We have this sodium which is produced. The sodium in the amalgam react with water to form hydrogen and sodium hydroxide. So you have seen that there is a mercury which is produced here. The mercury is normally regenerated and then it is recycled back in the process. So the mercury is regenerated and recycled into the main cell. And of course, you need to know the reason why mercury is the mercury is being recycled in this process. So what is about the importance of recycling of mercury? Recycling of mercury, one, it is to lower the cost of the production and also to minimize its pollution effect. Notice the mercury, it is a very poisonous gas, it can cause the brain damage. Therefore, one of the reasons why it is being recycled, it is to minimize its pollution effect. And if you need the advantages of this mercury cell, sodium hydroxide is a very pure, and it is very pure, and therefore it is highly concentrated. We are saying about 50% concentration. So the disadvantages of this mercury cathode cell is that mercury is very expensive to obtain, and also mercury can cause a brain. It can cause brain damage. Now, uses of sodium hydroxide. We have the production of hydrogen, we have chlorine, and then we have sodium hydroxide. Sometimes you will be required now to give some of the uses of each product. For example, what are the uses of this sodium hydroxide? Sodium hydroxide, in most cases, it reacts with chlorine to form a sodium chlorate. And sodium chlorate, it is normally used as a powerful oxidizing agent, which is used in sterilization and bleaching in textile and the paper industry. So it can also, you say that it can be used in making irons and also making of detergents. This sodium hydroxide can also be used in neutralization of acidic solution in the laboratory. So in most of the laboratories, it can be used to neutralize some of the acid. The acid that it can be used in the manufacture of detergents. It can also be used in manufacture of cosmetics and very many other. We have another product which is a hydrogen gas. Of course, if you require to give the uses of hydrogen gas, you have come across uses of hydrogen gas in Form 3 in organic chem, whereby it is used as an hydrogenation, a reagent used in hydrogenation, whereby it is used in a hydrogenation process of adding animal fats to oil. So hydrogen can be used there. Industrial processes, it can also be used as a raw material in the manufacture of hydrochloric acid, as a starting material in the manufacture of ammonia in the upper process. When you go to Form 1, water and hydrogen, one of the uses of hydrogen is when mixed with oxygen, it produces ox hydrogen flame, which is used in welding and cutting metal. And of course, we have another product which is chlorine. Chlorine can be used in the formation of sodium. Can be used in the formation of sodium chlorate. The sodium chlorate is normally used in bleaching in the paper industry. And now we have reasons why mercury is recycled. Why do we recycle mercury? Now here, mercury is recycled because it breaches any wax, it has irritating smell that causes headache at human beings. So and very many others. We have also that this why it is recycled. It forms it forms the hydrochloric acid and hypochlorous acid, which both of them they cause what we call the marine pollution, and therefore it can also lead what we call the stomach upset. Those are the reasons why mercury is normally recycled in the process. We have a current of 100 amperes was passed through the cell for 5 hours. Calculate the mass of sodium hydroxide. So in this case, what you need to understand here is that to calculate the mass is given by mass is equals to the quantity of electricity in that case. You multiply by the relative atomic mass of that compound, then you divide by N, then this one is multiplied by F. N is Q is the quantity of electricity required. This is the relative atomic mass of sodium hydroxide, of course. And then we have N, this is the charge, the amount of electricity required, the charge required now, the amount of electrons required. The Faraday's law, in this case, we are talking about the Faraday constant, and we know that 1 Faraday constant is equivalent to 96,500 coulombs. So, from this equation here, we need to have the quantity of electricity in that case is given by the current, in this case, times time. And remember, time must be, this time must be in seconds. So we have to get this time must be in seconds. So our quantity of electricity is equivalent to the current produced here passed through is 100 amperes, and it was passed for 5 hours. So convert 5 hours into seconds. So you have this one is 5 hours times 60 convert it into minutes times another 60, then you convert into seconds, and this one will give us 180,000. So we have this is 180,000 we have 180,000 coulombs. The RAM, so we can see that the relative atomic mass of, in this case, sodium hydroxide. So we have sodium is 23, so we have 23, so it's equivalent to the 23 plus. Oxygen is 16, and of course hydrogen is equivalent to 1. Then you add that one, this one will give us, that one gives us 40. The Faraday's constant, as you can see, is equal to P. This is 96, 500 coulombs, and of course we have our N in that case is equivalent to 1. So if we substitute there, mass is equal to P. The is 180,000 multiplied by the RAM, which is 40. So you divide by 1, 10 times in this case, and 6,500, and that one will translate to 746.113 in that case grams. So that is the mass of sodium hydroxide. The mass of sodium hydroxide. So it's a simple summary of the Mercury cell. Don't forget to follow my channel, subscribe, watch, and share. Thank you.